Skyline can be one of the most inspiring sights. Skylines remind us of heritage and history. The modern city skyline tells us how far we've come as a civilization. Unfortunately, it's not always beautiful. Yet, someone was responsible for the design of every one of those structures that make up our skylines. And I'm not just talking about the great tall buildings in the city, but about the barns and farmhouses, the silos and the bridges that make up our environment. Each of them is a structure, and a human being had to figure out how to make them do the job they were supposed to do, and to make sure they wouldn't fall down.
I'm Don Westwood, and I'm a professor of architecture. Now, most people think architecture is just about the way buildings look. But in this series, I want to tell you something about the science of architecture. In other words, the science of designing buildings and bridges and the like that won't fall down.
In fact, everything in the world needs a structure. Otherwise, it would have no shape, no volume. You couldn't put things inside or hang them on the outside. An egg, a cave, a tree, they all must have structure.
Animals and people have skeletons, and so do buildings. And it's no coincidence that the skeletons of buildings and animals and people sometimes look alike. But as we shall see, there's more to a skeleton than just the bare bones. The bones have to be held together somehow, and they often have to move. Well, that's part of the structure as well. In architecture, structure is what makes a building stand up, and as you might expect, it also has a lot to do with determining what a building looks like. Now, one thing we will find is that the basic structures that we now use for our bridges and our buildings, we can also find in nature. Very often, nature has solved a structural problem millions of years ago, and we've only just caught on. So, for the next 8 programs, we're going to examine how architects use scientific principles to come up with the structures that have made our urban and rural skylines what they are. Here's a quick guided tour of the 8 topics we're going to look at. It's a fast tour, so hang on to your seats.
This first program will illustrate how we rely on structures in our lives, both man-made and in nature. We will also look at the concept of building loads, the main forces a structure has to resist to keep from falling down. Program 2 will continue the discussion by examining the forces that loads create, that want to pull down a structure. They are compression, tension, shear, torsion, bending, and bending moments. In Program 3, we begin to look at how structures deal with these forces, starting with the roof. Historically, roofs were sloped or were domes, but today roofs are more often held up by trusses, and we'll show you how to make your own models of roof trusses using popsicle sticks. The program will also look at how trusses are used to hold up bridges and span very large areas. The fourth program deals with walls. We'll explain how compression works in a battered wall, why buttresses were developed in Gothic architecture, and what role walls play in modern skyscrapers. We'll also explain the principles of pre-stressing, reinforced concrete, post and slab construction, and cantilevers. Arches are the topic for Programme 5. We'll look at their great strength and durability and show you how to experiment with different arch shapes. Then we'll cover their three-dimensional cousins, vaults and domes. There are some very interesting examples to look at, such as groin vaults and fan vaults, to name just two. And in addition, we'll talk about several types of domes. From there we move on to shell structures in Programme 6. Once again, nature has led the way. These structures use some of the most complex curves in geometry, and although quite thin, these beautiful roofs are remarkably strong. And while it may seem hard to imagine, lattice-type domes are related to shell structures, and so we'll look at some of these exciting designs. After that, number 7 will cover structures that use suspension systems. That is, rope bridges, suspension bridges, cable-stayed bridges, suspension buildings, as well as related tension-based structures such as tent roofs and pneumatic domes. And finally, Programme 8